Hey everyone, so today we will be doing a physics paper, the February-March 2024 year, and let's begin. First question: which row shows a physical quantity and its base unit in the SI system? Current, ampere. Okay, so I can already see that this could be the answer. Let's check. B, force, Newton. So this is a derived quantity, so this cannot be an SI unit. Mass is a base quantity, but its SI unit is kg. Same with temperature, its SI unit is Kelvin. So answer is A. A car of mass 850 kg is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. One force has a magnitude this and one force has a magnitude this. What is the magnitude of the acceleration of the car? We know that resultant force, or F, equal to ma, or resultant force is 1600 minus 1200, which is equal to 850 a, or hence acceleration is 400 by 850, which is equal to 0.47. Hence that is your answer. Question 3. An object of mass m is suspended by a spring from a fixed point. The spring has a spring constant k. The object is set into vertical oscillations of period t. So k equal to f by x, right? Where f is the force and x is the extension, and period has a unit of s. So the left hand side always will have a unit s. So the right hand side will also have to have a unit of s. So let's see for part A. For part A, okay, let's first find out the SI unit of K, which is force is kg meter per second square, and at the below it is meters. So meters cancelled, which gives us kg s minus 2. So for A, okay, so 2 pi does not have any units, so we just don't have to consider it. We'll just consider this parts, right? For each of them we'll consider this parts only to match if the equation is homogeneous with respect to base units. Okay, for A it is, okay, so mass is m. Okay, so to the right hand side, kg s minus 2 by kg. So the units come s to the power minus 2, which is not equal to s. So A is wrong. For B, on the right hand side we have kg by kg s minus 2, which is equal to s square, which is not again equivalent to s, which is the left hand side. So this is wrong as well. For C, on the right hand side, we have a root this time. So the root kgs minus 2 by kg, which is s to the power minus 2, which when we root so this would be s to the power minus 1, which is also not equal to s. So that is wrong as well. Then part D, it is root over kg by kg s minus 2. The kg's are cancelled, equal to root over s square. Yes, this is s, and also equal to the s on the left hand side. Hence D is your answer. We'll move to question 4. An object of fixed mass is initially at rest at point P. The object then moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? Okay, so as it is uniform acceleration, the resultant force F is equal to ma. So A equal to constant means F equal to constant. So resultant force is constant, so it cannot increase uniformly with respect to time. It will have a constant value, because also mass is always same, always same, it never changes mass. So constant, so F equal to constant as well, so A is wrong. It is constant but not zero, it will have a constant value. So this could be an answer. It is proportional to displacement, which means if displacement increases, the F increases, which is wrong, because it will just have a constant value as this. It is zero, no, it is not zero, but it will have a constant positive value or maybe a negative value, but it is constant but not zero. So answer is B. A projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of velocity of 13 meters per second. So this is the motion at 25 degree is going with a velocity v, and the horizontal component is 13. So what is the vertical? So we first need to find out v. So v cos 25 is equal to 13, or v is just divide 13 by cos 25, divide cos 25, which is 13.11. Then use it to find the vertical component, which is sine 25, which is 13.11 sine 25. Wait 1 minute. 13 divided cos 25. 13. Oh, sorry, my calculator is in radian mode. So this one, I'm so sorry. Please check out if your calculator is in the correct mode or not. Okay, so 14.34 sine 25, 14.34 sine 25, this is equal to 6.1, which is equal to B. So I hope that is clear. Okay, a ball is released from rest at position X at time 0. At 1 second it bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce at this seconds. Okay, what is the total displacement of the ball from its original position X to this? So it will be the area of this distance minus the area of this distance, because displacement is after you move from point X to Y, and then again if you move from, let's say this is the distance, and if you again move from Y to a point Z, if you subtract this distance from the total distance, then you get the displacement or the shortest route that you want. So let's do then. So half into 10 into 1 minus half into 5 into 0.5. Put this in the calculator. 5 minus 5 into 5 into 0.5, which is 3.75. Answer is B. That is the displacement. What is the definition of acceleration? Acceleration is v minus u, which is final speed minus initial speed by time. It is change in velocity per unit time. Correct. Rate of change of speed per unit time. It is not the rate of change of speed per unit time. Rate of change of velocity per unit time. Not really. Resultant force. It is just the rate of change of velocity. If that's what you want to say, it is the rate of change of velocity, but not the rate of change of velocity per unit time, right? No, resultant force per. So this is F equal to ma, or acceleration is also equal to F by m, but this is not the basic definition. This is not the basic definition of acceleration. So that's why these two are wrong. Answer is A. Okay, we'll move to part question 8. Two balls spin cube of equal mass move along a straight line directly towards each other as shown. Ball P has a velocity this to the right, and yes, we can see the diagram which side the velocities are. P and Q collide with one another. The collision is perfectly elastic and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after collision? Okay, so relative speed of approach is equal to relative speed of separation. Right, so what is the approach? So approach equal to 1.3 plus 0.5 from this diagram. I'm just using the theory we know. that when two are going in opposite directions, as you can see, there's individual speeds are added or velocities are added. We have to see which one over here in the options have 1.8. Does this, they're going in the same direction, so they definitely will not have 1.8. This will also not have 1.8. This one will have, let's see, 0.99 plus 0.19, 0.99 plus 0.19, 1.18. So this is also wrong. That's also wrong. This too will have 1.8 meters per second. Hence, after the collision as well, since it's perfectly elastic, this law works, and hence the answer is D. A basketball player hits a ball vertically downwards with a speed of 2.4 meter per second from a height of 0.9 meters. So from a height of 0.9 with a speed of 2.4 meters per second at this direction with an acceleration of 9.81. Air resistance negligible means constant acceleration, which is the speed of the ball. So we will use this formula, or V square would be 2.4 whole square plus 2 into 9.81 into 0.9, or just use the calculator to find the value of this. 2 into 9.81 into 0.9, which is 4.8 meters per second, which is the speed of the ball as it hits the ground. Question 10. A ball falls through a liquid at a constant speed. It is acted upon by three forces: an upthrust, a drag force, and its weight. So it is moving downwards, so the weight is the highest value. As its constant speed, so resultant force equal to 0. So weight will be equal to upthrust plus the drag force. Let's say this is the upthrust and this is the drag force. The liquid has a uniform density. Okay, so drag force cannot increase, because if drag force increases, weight has to increase, which is not possible because the uniform downward acceleration is 9.81. So that is not possible. So that is wrong. The drag force is equal to the sum of the upthrust, drag force. No, we can see that the drag force is equal equal to W minus U. So that is wrong. The upthrust is constant with increasing depth. That makes more sense. The weight is greater than the sum of the drag force and the upthrust. The weight is greater. No, the weight is equal to U plus D. So that is wrong. Okay, so this one, we also know the upthrust equal to V rho G. Here, all of this constant. V is the amount of displaced liquid, which once the object is below the water, the volume of displaced liquid cannot increase further. The density of liquid is same and the value of G is always same. So we can see that our correct answer is number 10. Let's move to question 11. Some small solid cubes each have mass 1 kg and sides of length 5 cm. These small cubes are stacked together to form a large cube with sides of this. So in the entire volume of 5 cube, we have to determine how many in the entire volume, the small cube stacked to form a large cube with sides of this. So in the large cube's total volume, we have to find out how many of this small, this is 0.05 meter, solids or block cubes can fit in. So it will be volume by volume. So this is 8 by 0.05 whole cube, which is 64,000. So these are the number of cubes that can fit in the large cube. Hence, if you find out the weight, which is equal to mg, so the W equal to mg, or weight equal to 9.81 into 64,000 into 1, which is equal to 9.81 into 64,000, which is equal to this is 627,840. So we have to give it in mega newtons. So this is the closest to the answer, as we can see, as we have to give it in mega newtons. So these two won't be, the values are not even close, 0.39. So this one is the answer. Answer is hence C. You can try this out. 627,840 divided by 10 to the power 6. You can use your calculator and it comes to be 0.63. Hence C is your answer. A borehole of depth 2000 meter contains both oil and water as shown. The pressure due to the liquids at the bottom of the borehole is this. So pressure at this point is 17.5 megapascals. Density of the liquid is this, 830, and the density of the water is 1000. Yes. Okay, so this little height over here is 2000 minus x, and A is 9.81, G is 9.81, A equal to G is 9. What is the depth x? So the pressures at this point plus the pressure of this point is equal to 17.5 megapascals. And so we will do, so we will use the formula of pressure equal to H rho G. H rho G we'll use. So let's do it. So x into 830 into 9.81 plus 2000 minus x into 1000 into 9.81 equal to 17.5 into 10 to the power 6, or 830 into 9.81, which is 8142.3x, plus 2000 into 1000. I'm just using the calculator to find out the values now. You do the same too. 19621234 minus 1000 into 9.81, which is 9810x, or 9810 minus 8142.3 equal to 19621234 minus 0.5 into 10 to the power 6, or x equal to 19621234 17.5 10 to the power 6. I'm just solving the equation, nothing more. 10 minus 8142.3, this is equal to 1 minute, I placed a value wrong. Yes, the answer is 1270.5, which is near about to 1270 meters. So answer should be D. Question 13. This is interesting actually. A rod is pivoted at one end. Initially the angle theta of the rod to the horizontal is 0 degree. The weight of the rod causes a moment m about the pivot. The rod is then rotated in the vertical plane, so the angle theta of the rod increases from 0 degree to 1 degree. Which graph shows the variation of m with theta? Okay, so see, if the rod is initially horizontal like this, and later this is the horizontal and the rod is placed in some position like this, right? So here this is distance d, let's say, and this is distance d as well. D, this is some angle theta, this is the weight, and this is w cos theta. So m is the moment. So here the moment is simply the force into d. Let's say there is a force of F. Let's say here the force, let's say this time the this force actually the weight of the rod causes. I'm so sorry. So this will be the weight. They have mentioned it themselves, the weight. So yes, so weight. Then again this time we have to use the component, because the forces have to be perpendicular to each other to calculate moments, right? So this time the force, the moment will be w cos theta d. Here you can see a relation that m is directly proportional to w cos theta, or m is directly proportional to cos theta. So this will be the cos graph, right? It will be the cos graph, and we can see the cos graph only. If you extend it to the left, this would be somewhat. So answer should be D, because the others don't really show your cos graph. And with this relation, we have to see that the cos graph has to come on Okay, so that is that. Let's move to question 14. Three forces act on a hinge trapdoor is held closed in the horizontal position by cable. Three forces act on the trapdoor: the weight W of the door, the tension T in the cable, and the forces H at the hinge. So T will be equal to W plus H, which means the vertical component of T, which I'm just writing this way to simplify, and the horizontal component of H plus the W. Now the T will be greater than W or H. So T increasing order of magnitude. So T has to be the highest force. T is not the highest force there, so wrong. T is not the highest force there, wrong. T is the highest force here. T is not the highest force here. So answer is C. Definition of force: it is the rate of change of momentum. Rate of change. This is the basic definition. Okay, F is also equal to ma, but this is not the basic definition. So A will be wrong. I don't know what these formulas are for. A boat moves at a speed velocity v through still water. A constant drag force Fx. What is the power? So power we know is the force into velocity, which is Fv. Answer should be B. I don't know what these formulas are actually, but the answer should be Fv. Question number 17. The diagram shows four forces acting on a circular disc. Each force is a magnitude F. Two of the forces act vertically and two act to the side horizontally. All forces act in the same plane as the disc. No other forces act on the disc. The disc has diameter d. Which statement is correct? So the resultant torque here would be, so this is the distance d and this is the distance d. So that would be F into d plus F into d. So this is the resultant, because there are two forces parallel, this one and also this one, right? And also this one and also this one. So there are this amount of forces. So the torque is 2Fd. Let's see. Okay, so resultant force towards the right is F minus F, and also towards the vertical region also F minus F, which is 0, 0. So there is no resultant force because there is no. So equilibrium depends on resultant torque and resultant force. It does not only depend on resultant force itself. Not again, the disc is not in equilibrium because the resultant force is not 4F, it's 0. Because the resultant, so the torque is not 0. The disc is not in equilibrium because the resultant force is 2Fd, as we have just shown by the calculation here. And so the answer is D. A ball is projected into the air from horizontal ground and follows the path shown. So we can see the path. At points this, the ball has kinetic energies this respectively. The heights above the ground are shown. Air resistance negligible, which means half mv square is rightly equal to mg del h. So this thing is constant. So we have to just see about this. So let's see the smallest difference of Ke. So for A, EQ, which is 1.5 minus ES, which is 1.6, which is minus 0.1. For B, ES 1.6 minus ER, which is 1.8. This is equal to minus 0.2. So B is already wrong because already greater than A. C is ET 1.3 minus EQ, which is 1.5, which is minus 0.2. Again, this is wrong. D, that was ET minus EQ, right? Okay. Then we have ET, which is 1.3 minus ER, which is 1.8, which is minus 0.5. Again, wrong. The differences are too large, hence the answer is A. So we'll move to question 19. The battery of a small tablet computer is initially uncharged. It's connected to a constant 10 watt power supply for this hours to charge the battery. The efficiency is this, which is 0.8. What is total energy stored? So energy equal to power into time. Power is 10 and time is 2 into 60, which is in the minutes, and then the seconds. This will be also multiplied by 0.8 because the efficiency is that, and this should give you the total energy. 2 into 3600 into 0.8, which is 5.8 into 10 to the power 4 joules. Use your calculator. The answer should be C. The initial stationary firework explodes and splits into two fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E, and one fragment has mass m and the other one has mass 2m. What is the speed of the fragments of mass m immediately after explosion? So mass m's speed. So let's say this one has a speed x, right, and this one has a speed y, right? That and that. So 0, because initially it was stationary, so momentum before equal to momentum after. We will use the law of conservation of momentum, which is mx. Since they're move horizontally in opposite directions, so it will be like this, my 2my, or y is x by 2. Since we need the speed of the fragment of mass m, that is, we need to find out the value of x, so we need the terms in terms of x to find out the value of x. Then we will use the kinetic energy. E is equal to half into mx squared plus half into 2m x by 2 whole square, which is 0.5, cancel, 0.5 mx squared plus 0.5 plus 0.5 whole square, which is 0.75, 3 by 4 mx square, or when you bring it down there it would become mx square equal to 4e by 3, or x will be root of 4e by 3m. So where is this answer? It is visible here at D. So this one is just mark it by Wiles duration. It's a little trickier compared to the sums we have just done till now. So next question is question number 21. A spring is fixed at one end. A spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law, but relationship for the spring is correct. Okay. So we know that EP is equal to half kx square. So k is a constant, so we have to use the relation only between EP and x square. So answer should be D. Now many may ask why we won't use this. So this is not the general equation for finding an elastic potential energy, just like the general equations or definitions. So whenever a question of elastic potential energy's relationship is asked, always use this formula. Also think about this like this: EP is directly proportional to both F and both X. So one A and B both should be the correct answer, which cannot be, because in Cambridge there is only one correct answer. So these are wrong. This is wrong. Answer is D. A force extension graph is produced from a metal wire, which must be describe the limit of proportionality of the wire. The point at which the wire breaks, that is not the. So proportionality means until it obeys Hooke's law. The point beyond which Hooke's law is not obeyed, yes, the point beyond which Hooke's law is not obeyed, or before which Hooke's law is obeyed. So answer is B. 23. A spring has a spring constant of this. It is joined to another spring whose spring constant is this. A load of 80 newtons suspended from this composite spring. So both have 80 newton forces applied to them, because in series spring composite connection both will get the same force. So we know that extension equal to F by K. So here extension is 80 by 6, extension here is 80 by 4. When you add this to 80 by 4 plus 80 by 6, this should give you 33.33 or 233. Answer is D. Okay, the range of frequencies of sound waves emitted by blue whales is this. The speed of sound in water, seawater, is approximately this. So let's convert 1.5 to meters per second, which is 1500 meters per second. What is the approximate range of wavelengths or speed by blue whale? Since they are given in meters, that's why I have done it 2 meters. And so let's check it out. Okay, so we know that V equal to F lambda, or what we need is the lambda, and we found the V, and Okay, so lambda equal to v is this. Let's first use the minimum one, which is the 10 hertz, which gives you 150 meters. Then let's find out, okay, which you can already see, and then let's use this by the maximum one, maximum frequency, because we need to find out the range. So this is 37.5 or closest to 38. Answer should hence be D, because the range is 38 meters to 150 meters. Let's move to question 25. A sound wave is detected by microscope and displayed on the screen of CRO. The frequency is this. What is the setting of the time base of the CRO? Setting means per centimeter. So this is the time period. So this is T. So let's find out T. So 1 by 2500, which is 1 by 2500, which is 4 into 10 to the power minus 4. Okay, so this is for 4 units. This is 4 units. So for 1 unit, it will be divided by 4. Now, again, what we have to see is this either in seconds, or let's first see in seconds. In seconds, it would be 10 to the power minus 4, but in milliseconds also there is options. There are seconds, so those won't be the option, because if we divide this 2, it will only be 10 to the power minus 4 seconds. So we'll convert this to milliseconds, right, by multiplying it by 10 cube. So this would become 0.1 millisecond, which is per centimeter as well, minus 1. Answer is hence that. Answer is A. A source of sound wave with constant frequency moves towards the stationary observer. The observer compares the sound waves arriving at the observer position with the waves emitted by the source of sound. What is detected by the observer? So it's moving towards, means frequency would increase, lambda would decrease. A decreased frequency is wrong, no change, there is a change in frequency. A decreased wavelength, that is the correct answer. No change in wavelength, there is a change in wavelength. So this is just normal theory you have to apply here. Cannot be polarized. Which types of waves cannot be polarized? This is the longitudinal. Only transverse can be polarized. So radio waves are transverse, sound is longitudinal, ultraviolets are transverse, X-rays are transverse, because these are all the EM waves we know about. EM waves we know about, the electromagnetic waves. So answer is B. 28. Beam of light with power P has an area of cross section this. The amplitude of the light waves in the beam is this. So P equal to IA, which is intensity into area. Now the amplitude of the wave in the beam is X. The beam of light is then changed to one with same frequency but with an increased amplitude 4x and an area cross section A by 3. So we know also one relation, which is I directly proportional to A square, which is I equal to KA square. If we use equal to KA, because we're removing the proportional sign, we are introducing a constant, or the I equal to K into X square, right, or K equal to I by X square, right, K equal to I by X square. Then for the next one, we can see that again we need to write, let's write this I1 into KA squared, which is K is I by X squared into 4x whole square, right? So the x squares would be cancelled, which will give you 16i. So I1 equal to 16i, with the x squares cancel, 4 square is 16i. When we have done that, we will now move on to power equal to, again, intensity. Let's say this is also P1 now. So the intensity is 16 and the amplitude is 1 by 3. This is IA, which gives you 5.3. IA is also equal to the P, the initial P, so it is 5.3 P. Answer is hence B. So you can also give a star here. This is an interesting question too. Okay. 29. Two loudspeakers are connected to the same signal generator. The signal generator produces single frequency. The loudspeakers face each other so that a stationary sound wave is set up in the region between the loudspeakers. Okay, stationary wave is set up. A microphone is connected to cathode ray CRO and positioned between the two loudspeakers, right? The microphone is moved on a line joining the two loudspeakers. The signal of the CRO shows 5 maximum amplitudes, 5 antinodes it shows as the microphone moves. The microphone moves a distance of 2 meters. That gives the first maximum to the position that is the fifth maximum. So this, and this. So this distance right here is 2 meters. So distance between antinode to node is lambda by 4, and distance between antinode to antinode is equal to lambda by 2. This is one thing you have to remember. So lambda by 2 is equal to 2. or 1 minute. Um, Fifth maximum and the initial maximum. Exactly. There are actually four amplitude to amplitude distances. So sorry, I missed that. 4 into it would be. So this would be cancelled out, or lambda would be 1 meters. Answer is D. Two sources emit coherent waves means constant phase difference between them. Which condition must be correct for the coherent waves? Waves are emitted in phase, constant phase difference. The opposite directions, not must. The waves are emitted with constant phase. This is a must, right? So answer is C. The waves are emitted with same amplitude, not a must. So yes, so the answer is C. So the next question now, question number 31. A student sets up an experiment to investigate double slit interference. The student uses light of single wavelength from a laser to eliminate double slit so that a pattern of interference fringes is observed on the screen. You can see the setup. The student finds that the fringes are very close together. What could the student decrease in order to increase the separation of the fringes on the screen? So lambda equal to ax by d. So we need to find out the x here, which is lambda d by a. Here, according to them, the values are x equal to lambda q by r. So if we increase q or lambda, x increases. So if we decrease r, then only will our value of the fringes decrease. So answer is C. What are the definitions of potential difference and electromotive force, energy transfer by and charge Q? Both are W by Q. So answer should be B. Sorry. Answer should be answer should be A, because both of them are W by Q. Both have units of volt. So yeah. Yes, the diagram shows a network consisting of three resistors. It will be 2.2 plus combined resistance. So whenever you see question, you really have to do that much practice that you understand what the question could actually be. And when you're seeing this arrangement, you know that it has to be one of those, like to the power minus 1, one of those combined resistance questions. And yeah, 1.2 plus 1 divided 4.7 whole to the power minus 1. I'm just using the concept here. 3.2 kilo ohms. Move to question 34. A resistor dissipates 25 watt of power, then there is a potential difference of this. Where is the resistance? We know that power equal to V squared by R, or the resistance equal to V4 squared by 25, which is 0.64. Answer is B. Diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. The resistance of the variable resistor is decreased. So this resistance is decreased. So total resistance decrease, current increases. So current would increase the values. So these are wrong because the current increases. But since the resistance across this decreases, its voltage decreases. This is the theory. So resistance across component decrease, voltage across it also decrease. So answer is B. A radioactive source produces a beam of alpha particles in a vacuum. The average current caused by the alpha particles have a charge of 2e, and the beam is this. The beam is incident on a metal target. Where's the average number of alpha particles in 3 seconds? So first we have to find the charge, which is IT, which is 3 into 1.5 into 10 to the power minus 9. So just put that in the calculator. 3 into 1.5 10 to the power minus 9. This should be 4.5 into 10 to the power minus 9. Therefore, average means the total charge, which is just what we found out, by the charge of one of them, which is 2 into 1.6 into 10 to the power minus 19. This should give you the average number of particles that are traveling. So it is, the answer is 1.4 into 10 to the power 10. So answer is C. We'll move to question 37. The charge carriers in a metal wire are free electrons. Which statement about the charge of each free electron is correct? About the charge of each free electron. So they have a charge of minus 1.6 10 to the power minus 19, which is constant and unchanged. The magnitude of the charge increases. It is unchanged. The magnitude of the charge is 0 unless there is no. It is not 0. It has a value even if it's negative. The sign and magnitude of the charge do not depend on the potential difference across the wire. That makes sense. The sign of the charge depends on the potential. No, it does not. It is a constant value and does not depend on these factors. I have a charge of plus. So you remember this trick. UCT DSB, which have charge 2 by 3e. This have charge minus 1 by 3e. So this is up, charm, top. This is down, strange, and bottom. So which flavors have a charge plus 2 by 3 e? So it is U, which is up, not there. Charm would be one of the answers, and one will be top. So answer should be A. So an unstable nucleus of an element decays by emitting an alpha particle or a beta particle to become a nucleus of a different element. This nucleus is also unstable and emits an alpha particle or a beta particle. The process continues until an isotope. Very interesting. So what is the minimal number of possible particles? So whenever this is a common technique, it's a shortcut. You can definitely try it out by creating the equations, remove the alphas 4 2, remove the alphas, remove the betas, and then you can obviously form the equations and try. But in exam you need to save time, and because it's not like you may have done all the previous sums in your first attempt, you may have stopped on one of them. So what you will do is you will just remember this trick. For an isotope, it will always be 1 alpha particles released and 2 beta particles released, beta minus. Then only if these 3 particles are released, then only an isotope forms. So whenever an isotope question comes, you just memorize this is a shortcut, that 1 alpha and 2 beta minus have been released. So answer is 3 particles, and the answer is B. So we move on to last question 40. A nucleus of carbon 10C carbon decays by beta emission to form a nucleus of boron 10B boron. For this decay process, what is the change to a nucleon, and what is the change in the quark composition? So it is 10,6 carbon, which is forming 10,5 boron, plus what is it emitting? Oh yes, it is emitting a beta plus, because one has reduced, one has increased there. So this is converted to a proton to a neutron. This is a common theory I'm just using. Proton to a neutron. So C and D is wrong, and it would become UUD to UDD, means one U is converted to one D, so up becomes down. So answer is hence B. So that is your entire paper. So let me just show you one more time this entire paper. That is page 1, page 2, page 3, page 4, page 5, page 6, page 7, page 8, page 9, page 10, 11, 12, 13, 14, and your last page 15. I hope that video was helpful, guys. So that is it for today. I will be next posting on maybe a biology or chemistry paper one next. So please comment down if these videos are any way helpful. It really means a lot. Give feedback on where I can improve, or just comment down if you have any confusions regarding these questions. And yes, so that's it from this video. Bye guys.